Right. This is an introduction to arrow diagram basics. We're going to walk through these three equations and see how we build the arrow diagrams for each of these. So in every case, we're going to start with the independent variable, or x in this case, and then we describe one step at a time the way we would follow order of operations, what happens to this x. And the first thing in this case is a multiplication by 3, which I'm going to represent that way. I'm going to put a lot of empty sets of parentheses on these arrows. They are making reference to where the thing at the input side of the arrow would go. So if that x drops in there, this becomes a 3x. It won't always be necessary to write this part in there, but we're going to do that for now. The next step then is we now have a 3x, and we're going to add an arrow onto the picture because we don't have everything that's on the right side here yet. And the 3x, what happens to that is we subtract 5 from it. Okay. And so if the 3x drops in that empty set of parentheses, then we end up with a 3x minus 5. And there is one step left to do there because this still doesn't say 3x minus 5 divided by 2. So we'll put this over here, and empty set of parentheses divided by 2. We could have done multiply by 1/2. We have some options there. And this gives us finally the 3x minus 5 is in the parentheses on the top. We don't have to write them there because the fraction bar implies that for us. And we get 3x minus 5 divided by 2. And so this set of 3 arrows is the arrow diagram for that first one. Okay. For our second one, we start with the x again. The first thing that happens to this x is it is being squared. So we're going to write that this way. We could use a caret symbol in there if we wanted to, but we want to leave that empty set of parentheses in there, and that gives us an x squared. And then the next thing that happens to that, we have to be a little bit careful with this, but really the next thing that's happening is there's a negative sign showing up in front of that. We could do that a number of different ways. I'm just going to represent that as a sign change that way, and it says put a negative or change the sign on whatever is at the beginning of that arrow. On the next step then, we can, to modify that negative x squared, we are going to add 5. Okay, if that drops in there, I get a negative x squared plus 5, but because of the commutative property, that's the same thing as 5 plus negative x squared, or 5 minus x squared. That whole 5 minus x squared now shows up under a square root symbol. I'm not going to put parentheses under that square root symbol. That's kind of implied there, but everything that's at the input side of the arrow ends up under the square root symbol. So my 5 minus x squared ends up right there. And then I've got one more that I need to do, and that's going to be adding 4. So the whole thing, the square root of 5 minus x squared, gets put in that parentheses, and the plus 4 is on the outside of that, not inside of the square root. So this set of 5 arrows is what we have for this one. And then finally, for our last one, we're going to throw a couple of complications in here. Start here a little bit lower with the x. And the first thing that happens there is it gets put into the exponent of e. So we write what we have there. We've got e to the x. And then just like on the last problem, I need a sign change in front of that. So I'm going to do the same thing that I did before, and now I have a negative e to the x. And like we did before, I'm now going to add 3 onto that. And that's going to give me a 3 minus e to the x. But now I see that 3 minus e to the x is in the denominator. I need to get it there. I'm going to do that with a reciprocal. Okay, what I like to call the flip it over function. So that will leave me with a 1 over 3 minus e to the x. But it wasn't 1 over that, it was 5 over that. So I'm going to need to multiply by 5. And 5 times 1 over 3 minus x is 5 over 3 minus e to the x. And then I take the natural log of the whole thing. I guess I shifted to the black pen there. And all of that then goes inside the natural log. I end up with a natural log of 5 over 3 minus e to the x. One of the ways I can check along the way to make sure that I'm doing this correctly is that every intermediate step that I follow along the way here, this e to the x should show up in my original problem somewhere. Negative e to the x should show up in my original problem. 3 minus e to the x should show up in my original problem. Okay. Eventually here, the 5 over 3 minus e to the x shows up in my original problem. I can always point to some place in there where that showed up in the original problem. So that's the basics and some of the tricks of a couple of places on how to make arrow diagrams.